Question number 40 can be very intimidating because what happens is when you look at this, which is a word problem if you're looking at your handout, a lot of times you have a lot of negative associated with worded problems. Just sort of like, okay, that's not a problem I can do. But one of the things that I want to try to point out to you with the way 1033 has been taught this semester, a lot of these worded problems are not like the stupid kind that you've seen before with the trains and the boats and the trucks and things that really weren't very interesting. This problem involves a model, which basically is a function that's being used for a particular purpose. So I'd like to read the problem to you. Sales of SUVs increased dramatically between 1991 and 1999. So right now you know this model is good between those years, 1991 and 1999. Growth in the sales could be modeled by a linear function. So in other words, the number of SUVs are growing, the number of purchases made are growing, and it's also a linear function by which this growth can be measured. So here's the model you're given. F of x is equal to 0.274x minus 539.5. Now, that means nothing to you unless you know what the variables represent. Well, if you continue reading in the problem, it tells you x represents the year. So that is the exact year, 1992, 1991, 1994. It wouldn't be the year 2005 because that year is out of this model's domain. You're not allowed to put that in. F of x, which is the answer, the y value, is going to measure the number of SUVs sold. And remember, the number is in millions. So when you put an x value into this function, if you come out with an answer like 5, think about that. That wouldn't be logical to say that in that year 5 SUVs were sold. The number that comes out is measured in millions. So 5 would really represent 5 million. The question here is to find the number of SUVs sold in the year 1996. So what we really need to do, there's really not a lot to this problem. Let me take you to my paper. Let me show you the function. All right, here's our function for problem number 40. F of x is equal to 0.274x minus 539.5. That's the model. That tells us, x tells us is the year, what year you're talking about, and f of x tells us the number of SUVs that were sold that year. So if we were asked to find the number of SUVs sold in 1996, we would go to the function f and we would put in the year, 1996. And that would tell us the number of SUVs sold that year. So basically, I'm going to take 1996 and I'm going to put it in the place of x. And in this particular model, x only appears, when we're evaluating the y value, x only appears once. So we have 0.274 times 1996, and then of course minus the 539.5. So to get your answer for this problem, we need to simplify that. Well, I know what I would do at this point is I would pull out my calculator. I'm not about to do this by hand. I would take my calculator, 0.274 times 1996, hit enter, in other words, get an answer to that, and then minus 539.5. And when I did this on my calculator earlier, I came out not with an exact answer, so I'm not going to say equals, but I'm going to say approximately equal to the number 7.4. Now what you need to remember, 7.4 would be absolutely ridiculous as the total number of SUVs sold. That doesn't even make sense. But remember that our y value, which is our answer, is actually in millions. So, what we've done By putting 1996 into the function that was modeled, we came up with the answer. Approximately 7.4 million SUVs were sold in that year. So, let me turn this back around to me. I don't want you to let wording in a problem throw you off, especially when it's a model. Pay attention to the wording, because the wording is there to help you understand what goes into the model and what comes out of the model.